Right. Hello everyone, and welcome back after the short turnaround. To those of you who were here a while ago, before we start, I want to make sure the audio is fine, the visuals are clear. If it looks like the screen is very fuzzy, probably you just need to select a higher resolution wherever you're at. So, at least from what I'm seeing, it should be good enough. If everyone has issues, then I'm sure we will find out in the chat. No, yeah. As always, this is the same intro that you have seen for all the videos. It's sort of also a bit of time for anyone to join in, but especially for those of you who are just entering this as the first time and you had no reason or no interest in the junior or senior categories. This is the open section. Our session will last probably somewhere between 2.5 to 3 hours. It seemed to go a bit faster this year. Not that the paper is easier, but that the number of questions that had lengthy solutions is slightly less. Now, it's not easier to think of, but it is shorter once you figure out what to do for, let's say, maybe 2/3 of the questions. So that's why the junior and senior seem a bit shorter. And yeah, we may be able to finish in 2.5. We're still going to go through all the questions, so if you were one of those who felt that, oh, I can do the first 5 questions, no issue, then yeah, feel free to step aside and come back in a little while. Right? This will remain on YouTube for as long as YouTube is around. Yeah. So as usual for stuff in the chat, let me know if there is serious lag, if I'm saying something and you can't hear me. More importantly, if I say something that's incorrect, just feel free to highlight, because this can happen. If you have an alternative approach, let me know. And what not to do is don't spam, don't say anything offensive, do not insult each other, whether directly or indirectly. So something insulting would be, let's say, oh no, I only got 24. That is also insulting. It's trolling, but it is also insulting for someone who is new to this. So just be nice. Yeah. And about cutoffs, which I said during the process of going through the questions, hopefully not too much discussion. In terms of cutoffs, the one thing you must remember is that no one really knows what the cutoffs are going to be. Right? Everything is speculative. So when someone suggests a score, this is just their opinion. And I've highlighted this before, but just to reiterate again, a harder paper or easier paper really depends on what is your target. If your target is 5 questions or 6 questions, let's say for an honorable mention, it does not matter how difficult the most difficult 5 questions are. The most difficult 5 questions could be actual IMO problems, and it has no relevance to you if you're trying to get 6 or 7 marks. On the other hand, if you're trying to get into the second round, which is usually, right, over the years, it has ranged everything from like 12 to 15, right? And it could go up or down. Then it depends on the middle block of questions, right? That means after you clear the first 7 or 8 easier questions, how many more can you do? So even if the paper looks very difficult, like there are 10 impossible questions, that may not affect the cutoff at all. And that's the reason why it doesn't always move in the way you expect. So don't overly speculate. You've done your best, and that's more important. Yeah, so the same thing, especially for open, I will not be able to go through all the computations. So if let's say I'm going to mention that, oh, this is just going to be a quadratic, I might just say, okay, the quadratic is going to have these solutions. And I may not even go into, okay, the quadratic formula or the factorization. I'll just jump a few basic steps to save some time. And also to focus on really what's going on for each problem. Like what sort of things are you supposed to notice? What sort of things are you supposed to actually prioritize when attempting these problems? Also, if there are any less well-known results or theorems, I will explain them, but I will only be able to explain what it says and how it applies to that problem. Right? For instance, I will not be able to give the entire theory of Pell's equation, which a few of you know is coming up at the later problems today. Final note, this is not an official production from the Singapore Math Society. The logo is there in recognition that the competition is organized by the Singapore Math society. Part of the reason why I'm doing this is to sort of, make resources about the SMO a bit more widely available. And so I'm happy to see that there are more resources available for the SMO now. Both for me, from some of my teachers have been doing this for a while. My ex-teachers, Dr. Lee Chen Lai. Currently, I also know that Mr. Chen Hongming has some resources. So all of these are good, right, for all of us in Singapore to at least have some resources available, not everything being hidden behind a paywall. So it's a good thing. And another note is that since it is not official, my solutions may not be what is intended. If my solution is like yours, then good for you. It doesn't mean it's the best either. If my solution is even worse than yours, then let me know. And possibly once in a while, I may have a solution that even the problem setter did not intend. That always happens. Another thing is that, there is a second round this year, and all of you are asking about those cutoffs already. One cutoff we cannot discuss is the gold cutoff, because that depends on round 2. And in round 2, for open, which is really difficult, one question is worth 10 marks is enough to cover almost the entire range of people's scores in round 1. So it is really early to talk about the gold cutoff. But if you think you would be able to qualify, like let's say you are well clear, you have like something like 17 or 18, don't worry about the 1 or 2 marks, because second round is going to be the main determining factor. Right, so and another thing, just if you have any friends who have taken the SMO Open together with you today, and you all have been arguing about some problems, and you are looking for an explanation, or just to find out how someone would be able to conceivably think of such an answer, just do invite them in. It is going to last for quite a while, so if they join in now, they're not going to be missing too much. Alright, so let's get straight into question 1. Now, before I actually get into question 1, I want to say that there are quite a few questions in the SMO that will always be recurring in terms of their idea, right? And that's the purpose of preparation. But there is a limit to how much you can prepare. There will always be questions you have not seen before. So it should hopefully reach the stage where your score is not literally just how many questions you have seen before. It should be based on how much you can reason. Now, having seen a question before will obviously save you a bit of time, but that shouldn't be how you score all your marks for a SMO Open. Right, so that's one final note before we go through the first problem, which is the sum from k equals to negative 2021 to 2021 of 1 over 10 to the k plus 1. One funny thing I noticed is that almost every single question in this year's SMO Open seems to have just put a floor function around it. It's as if the organizers were scared they make a calculation error and the answer is not an integer, right? I'm just scrolling through. There's question 1, question 2, question 4, question 5, question 7, question 8, question 9, and so on. You see that there's like floor functions around everything, and most of the answers are actually integers without the floor function. When you start to see that happening, you can kind of guess that, okay, this is just they are being safe, but you should still aim for an integer answer without the floor function, because there's a weird quirk about this year's paper where almost all of them are actually integer answers, and yet they just put floor functions everywhere. Don't know why. Okay, so question 1. When you have a long sum like this, those of you who are my students have heard me say this many times, there are usually only 3 different ways in which you can deal with a big summation. The first is that it's a well-known formula, let's say an arithmetic or geometric progression. The second is that you will be able to pair some stuff up, and each pair sums up to something nice. The third is that it's going to telescope, like a method of difference. Things are going to cancel out. That's usually the 3 ways it will go. And if you don't know a well-known formula, it means that it's not well-known enough, so that's probably not how you're supposed to do it. Now, the negative 2021 to 2021 is suggestive of pairing things up because they have deliberately made it symmetric. So that's what I'm going to do. I'm going to pair things up. And I'll just write it like this, right? In general, I want to see how they will interact together if I have n and negative n. Now, for the first one, there's nothing that can be done. For the second one, I can multiply the top and bottom by 10 to the power of n. And lo and behold, this is just equal to 1. So it means that each pair sums up to 1. The only thing that is not paired up is when k equals to 0. Now, at k equals to 0, this is just 1/2. So you have 20, 21 pairs summing to 1 and then a half. So S is 20, 21 and a half. And 2S is equal to 4043. I'm sure some of you will have forgotten that 1/2. These things do happen, right? So for the SMO Open, whenever you solve a question, one question is very valuable, because the later one questions are not going to come as easily as this. So double check your calculations, make sure you have not missed anything. I think it's something that you are painfully aware of for many of these problems. Okay, question 2. Yeah, again, I found this pretty weird, but it is not a very simple, it's not a very complicated question. It's just that it's worded in a rather awkward way, which is that you have positive integers, you group them into groups of size 2, then 4, then 8, then 16, and so on. And then they ask you for the sum of all the positive integers from G1 to G8. Effectively, what you just need to know is, well, so what numbers do they include? Where does it go until? And the number of numbers is 2 to the n, so you just need to add up 2 plus 2 squared until 2 to the power of 8. You can use your geometric series formula, or you can just use the fact that when you add up your powers of 2, if you include 1 plus 2 plus 4 plus 8 all the way until a certain power of 2, it will just be the next power of 2 minus 1. So one way or another, you would find that is equal to 2 to the 9 minus 2, which is 510. Now, 510 is going to be 1, 2, 3, 4 until 510. Everything's included. There's no other condition. So S is just adding up from 1 to 510. I take this as the token APGP question that needs to come out in every SMO Open in recent years. There's been a recent shift to try to align some questions with the A-level syllabus. So a few of the major topics always have shown up. Not exactly everything. For example, there wasn't really a calculus question this time, but some of the topics will always show up. So yeah, another of these kinds of calculations, do be careful. Check it, because every mark is very precious in the SMO Open. Plus, this is the only calculation that can possibly go wrong. Well, apart from being off by 1 earlier in the working, just calculate this carefully. Okay, so this is one time where the floor function is needed. And the answer should be 1303. When I say the answer should be, if I've said anything wrong at any point in time, please highlight it. This is not with a set of answers that has been verified. So I'm just using whatever I figured out, and I've been doing this around the SMO senior stream that some of you have been in. So I just did a bit before that and a bit after it. So a lot of this is almost like a live solve, right? I just quickly brush through everything to try to come up with reasonable solutions, and I could have missed a nicer solution somewhere. Okay, question 3. This is unfortunate, humorous / not very humorous question. A sequence of 100 positive integers, x1, x2, x3 until x100, are such that x1 squared plus 2x2 squared plus 3x3 squared plus 4x4 squared all the way to 100x100 squared equals to 338350. Find the largest possible value of x1 plus x2 plus x3 all the way to x100. Yeah, this is another pretty unfortunate question. You might think that this is an inequality because of largest possible value. But then you also see positive integers, which is a little bit suggestive. For some reason, I found that this 338350 was very familiar to me. I felt like I'd seen it in the past SMO open paper. One of the papers, this number just looked vaguely familiar. So I sort of recalled that it had something to do with sum of squares. I have computed this before and found this. Now, very unfortunately, it turns out that if you just sum the squares from 1 squared to 100 squared, it is precisely equal to that. Right? The sum of squares identity is 100 times 101 times 201 over 6. And as I said, very unfortunately, it turns out that, yeah, that is precisely it. So this is going to be a lower bound on the left-hand side. So equality must hold, and basically everything's 1. Yeah, so I've seen some SMO open papers that are full of these, and maybe this one is somewhere in between, where there are a few questions of like, let me stare at this, doesn't that work? Oh, it works, and that's the whole solution. It does happen. Okay, so necessarily the answer is 100. Yeah, the SMO open is sort of like a free-for-all, right? Anything could work, from the most silly solution to the most complicated solution could be the thing that you use. So you really need to consider everything. Yeah, so how I like to think about it is, for some of you, you do a bit of programming, right? So I like to think of it as, if you want to find the algorithm to the fastest solution, think of it as, you shouldn't be doing a depth first search, you should be doing a breadth first search. You should be considering all the possibilities, not just saying that it had better be Cauchy-Schwarz, or it had better be QMAM or something, and, you know, just insisting on it, and then if it doesn't work, you get very annoyed. It can work, but usually you want to try the most obvious thing first. If the most obvious thing does not work, try the next most obvious thing, and go in that order. Maybe that's not breadth first search, maybe that's more like Dijkstra, but never mind. Reference that a few of you get, the rest of you have no idea what I'm saying. Okay, question 4. Again, strange wording. A and B are two real numbers satisfying A less than B, and such that for each real number M satisfying A less than M less than B, the circle meets the parabola at 4 distinct points in the Cartesian plane. Let S be the maximum possible value of B minus A. Now, this is a very, very, very convoluted way of just saying what is the range of M such that this happens. Right, and the range of M is going to be AB. It's just really weird, right? And so the only thing that really matters here is 4 distinct points in the Cartesian plane. Whenever you have these kinds of number of intersections, number of meeting points, whatever it is, number of solutions, it is in order of obviousness. The first thing you want to hit is just, can I use the discriminant? And yes, you can use the discriminant. We know that this is going to be symmetric about the y-axis, and same for the parabola. Right, so roughly speaking, to draw a very, very actually, you know how the parabola looks, right? It appeared in a later question as well. I'm not sure again why they are doing this, where they have like repeated ideas of the same question twice. But yeah, what is going to happen is simply that your parabola is here and your circle is centered somewhere about the y-axis and with radius 5. So I mean, it could be something like this, but that will only have 2 intersection points, right? You want it to be something like this, where it has 2 intersection points, and because my drawing is not very symmetric, I have to actually draw an oval instead of a circle, but you get my point. Maybe I should just try to adjust it. So something like that. It's still just as bad, but never mind. I have given up by this point. Anyway, discriminant. So what I'm trying to say is that because the intersection points are symmetric, you just need two different y values. So if you substitute in, it becomes 4y plus y minus m squared equals to 25 should have two solutions, two roots. Because the two values of y will give you four values of x due to symmetry. Yeah, it's the worst circle and parabola you've ever seen, right? I'm trusting that you have seen the diagram later for the question 20 or something, so you can use that in your mind instead of what I've drawn here. Yeah. And then we'll go with discriminant. Oops, I forgot to write the 4y. 4y plus y squared minus 2my plus m squared equals to 25, and do the usual stuff. Okay, so the discriminant should be positive. Now, positive is a good thing, right? If you were greater than or equal to, then the inequality here should also have been equal to. The fact that there isn't means that we are probably on the right track. Okay. So you may notice something a bit odd here. And the thing that is odd is if you work out all of this, you get m is less than 29 over 4. Yeah, so that's odd because it doesn't actually seem to give the other left endpoint, right? Now, why is this happening? Now, this is happening because once you have done a substitution, this tells you all values of m for which there are two values of y satisfying this. Now, that does not mean that those values of y actually give you values of x. It's not guaranteed. So in order for these y to actually give you values of x, 4y equals to x squared means that there should be two non-negative roots, which is the additional thing to take note of. You should have two non-negative roots. Now, for it to have two non-negative roots, is if and only if the sum and product is non-negative. So the sum and product is non-negative. Actually, I should say positive because if it was 0, then it would just have been a repeated root at 0, 0. And that will not give you 4 distinct, that will give you 3. So I should remove that equality. Yeah, so greater than. So it means you need 4 minus 2m to be negative. Right, because the sum of roots is going to be negative of that. And the product of roots is going to be positive. Yeah, so this one tells you that m is greater than 2. This one tells you that m is more than 5 or m is less than negative 5. Put together, the one that works is m equals to 5. So you have got now the two endpoints obtained in two slightly different ways. Okay, so the range is going to be 29 over 4 minus 5, which is 9 over 4. Okay, and yeah, this time the floor matters. Okay, question 5. Yeah, so question 5 is humorously enough something that for some of my students, you have seen this question. I've used it almost exactly in one of my mock papers, And it does have a name, right? This actually, this is known as the British flag theorem, I think. And well, let's draw in PC. Now, what the theorem says is simply that PA squared plus PC squared equals to PB squared plus PD squared. The reason for that is by Pythagoras. So this is one of those things where I can justify without needing too much work. We draw these here. Then 14 squared would be this squared plus this squared. And 5 squared would be this squared plus this squared. Pythagoras. 10 squared would be this squared plus this squared. And the unknown PC squared is going to be this squared plus this squared. So you can tell that we are just squaring the same 4 things in a different order, so therefore the sum is going to be the same. Yeah, so we can just fill in the values and collect our winnings. And yeah, this time again, the floor function is redundant for this question. You probably shouldn't trust anything about the scale in this question because if we are just looking at this here, the 5, 10, and 14 look very, very not to scale, right? It's really, really not to scale. Right? The 5 is almost as long as 14. So you don't want to trust anything about the scale in this question. There are questions where there's only one way to draw it. If there's only one way to draw it, it has to be to scale. For example, if I tell you that inside an equilateral triangle, inscribe a circle. Now, how can you not draw that to scale? Unless your triangle is not equilateral. But I mean, you can't really not draw it to scale. If let's say that I tell you that take a 3, 4, 5 triangle and it really looks like a 3, 4, 5 triangle, then that is already to scale. There's only one 3, 4, 5 triangle up to similarity. But if you have something like this, the 5, 10, 14 are simply not in that proportion. So if they're not in that proportion, then there's nothing else that can be done. Okay, as with the other streams, maybe we'll go up to something like question 9 or 10 before we take our first break. Okay, question 6. Unfortunately, this question sort of favors anyone who has been doing Olympiads for a fairly long time, because if you're doing Olympiads for a fairly long time, this is a sort of question that can potentially be asked for primary 5 or 6 actually, because they love to ask this sort of questions on area for that level, because it's like the only thing you need to know is half times base times height, and then they imply that those are very easy questions because that's all you need. So the rectangle has area 180 and both of these triangles have areas 60. Now I was mentioning about half times base times height and the ratios. What's the relevance? The relevance is that if you have half of the rectangle, half the rectangle is going to have area 90. So if these triangles here are 60, it means that they are divided in the ratio 2:1 and 2:1. Right? They take 2/3 of 90. So that means that we can find the area of this small triangle here. This triangle is, because of similar triangles, right? 1:2, 1:2. This is 1/9 of BDC. 1/9 because 1/3 squared. So this area has 10, and the remaining area is just going to be 50. And that's it. Right? You can tell that thus far everything actually flows quite quickly, and this is what I meant, right? A lot of short solutions for many of these questions. That's not easier, you know. It's like if you know what to do, you get it done quite fast. If you don't know what to do, there's only 2 steps. So if you don't see that 2 steps, you are quite stuck for many of these. Okay, question 7. Now, question 7 is, I mentioned earlier about the token APGP question. Now, this is kind of the token vectors question. It's the token vectors question because it is asking you for distance from the origin to the plane. That is essentially the standard vectors question, right? It's a projection, and you need to find the equation of the plane, find the normal vector, and all that. I mean, it is possible to do it without vectors at a stretch, but that's kind of like if you do it without vectors, it's more like you are recreating the theory of vectors without explicitly invoking vectors. So it's still vectors. That's what I'm trying to say. Now, we need the equation of the plane ABC, or more specifically, we need the normal vector to the plane. So normal to ABC, we can just do something like AB cross with AC. Negative 2, 2, 4 cross negative 3, 2, 6. So calculate the cross product. Now remember that the cross product is called the cross product because it means that for each of the components, you cover that up and then you take a cross. Now that is kind of like the discriminant, but I'm just going to say cross. So 2 times 6 minus 2 times 4 is 4. And then after that, for this one, you cross those two. Negative 12 and negative 12, so that would be 0. It's supposed to be negated in your cross product for the middle one, but it doesn't matter here because it's 0. Then the last one is you cover the bottom and you cross these two. So negative 4 minus negative 6 is positive 2. So the normal vector is 402, which I think for computational purposes, I would just use 201 because you can scale up and down normal vectors and they're still going to be a normal vector. Now here's the truth, right? Every time when I have a projection question, I don't remember the formula. I derive it every time. So let me explain how I think about it. If you have ABC and let's say the origin is not on it, you want to find out what is the height, the distance. Oh, it's supposed to be x, isn't it? Now this is in the direction of the normal vector here. Right? And what we do is we project one of them onto here, meaning that the length is going to be just in this right angled triangle, OA cosine theta. And when it's cosine, you remember that is the dot product. So actually, this is just going to be 600, this is OA, dot with the normal vector, sorry, the unit vector of 201. This is very convenient. Okay, I'm just going to extend my, because it is just 12 over square root 5. Okay, so therefore, this is x, by the way. So 5x squared, again, the floor is not necessary for this question. It's just going to be 144. If you have not learned any vectors at all, to be fair, it is not really a good way to spend your time before the SMO, like in the past few days, to have learned vectors from scratch if you don't already know it. And because there's a lot of small little nuances which may or may not be important, and you won't know which ones to study unless you cover the whole topic. So I think that's not the best way to spend your time before. But after the SMO, if you're a JC student, you will cover this, of course, at some point. If you are not, you can start picking it up. Okay. Question 8. Now, question 8 can be done using a few different methods. It can be done using trig substitution, can be done using Cauchy-Schwarz. But I think the easiest way to do this is just geometrically to understand that these are equations of circles. So we'll go with that. Now, x minus 2 squared plus y minus 3 squared equals to 4. Yeah, there's a lot of quad geom-ish questions in the senior and open this year, right? That's true. I mean, there are quite a lot of questions that have allusions to quad geom, even though you don't really use much quad geom at all, which is kind of funny. Okay, so x minus 2, y minus 3 squared equals to 4. So the center is 2, 3, and the radius is 2. You want the largest possible value of x squared plus y squared, and that just means what is the largest possible distance from the origin, right? This is just distance from origin. Squared. So the furthest point is clearly going to be if you go to the center and just carry on in the direction further by the distance covered by the radius. The radius is 2. So yeah, that's basically how far you want to go. Now we do need to do a little bit of work to find out where's that point. Alright, so use a bit of similar triangles. Here this x would be equal to 2. And the length would be square root 13. Wait, hang on a second, am I saying something wrong here? Oh no, yeah, it's the square of the distance, right? Yeah, so, sorry, no similar triangles, what am I saying? Pardon me? Yeah, it's just square root 13 plus 2, right? Sorry, must have confused you for a bit. Yeah, I was wondering where's the 17 gone from my working earlier on. I forgot that I had to square it first, right? So, the maximum distance is going to be square root 13 plus 2. So s is going to be the square of this, which is, yeah, that's where the 17 comes from. Yeah, and then the latest installment of an unnecessary floor function again, because s minus 17 squared is 4 root 13 squared, which is 208. Yeah, sorry, that is not very clear, right? I'm just calculating the distance from 0, 0 to 2, 3. So the distance from 0, 0 to 2, 3, this portion here is just square root 13. And then that is 2. So square root 13 plus 2. Yeah, again, you can do this using Cauchy-Schwarz. You can do this using a trig substitution and potentially even using some calculus. But I think the most straightforward way would be using this plain quad geom interpretation. Okay, question 9. Now, question 9 seems to be just a donation relative to how difficult some of the other questions are, because all you need to do is to solve it, and it is solvable. There is actually nothing special about this. This is just a quadratic with the variable being w squared. So you can factorize it. 1 and 9. I'll write it as w squared is between 1 and 9 first, instead of factorizing further. It's just a bit easier for me this way, right? And I can square root it to say that the absolute value is between 1 and 3. Yeah, so maximum value of this, subject to the condition that the absolute value is between 1 and 3. So it means that either 1 to 3 or negative 3 to negative 1. Yeah, so since it's w cubed, it is fairly intuitive that the maximum value will occur when w is 3. If you want to verify that, you can just say that, well, from 1 to 3, this is an increasing function. And if it's negative, clearly this is going to be less than 18, right? It's very obvious, so we don't need to bound it that tightly. Yeah, for the previous one, how do we do it with Cauchy-Schwarz? I think what you can do is to substitute a equals to x minus 2, b equals to y minus 3 first. And then after that, you will end up with the largest possible value of 4a plus 6y. And you can get the largest possible value of 4a plus 6y from the a squared plus b squared equals to 4 via Cauchy-Schwarz. Okay. Last one for now is question 10. This is the sort of geometry question where there are so many different ways to do it, and all of them sound reasonable. Right? So there isn't really a hard and fast, you must solve it this way. It's completely up to you. But if you're stuck, then it means you are probably not making full use of the information. Okay, so what's the information? We are given 3 equal lengths. We are given 80 degrees and 160 degrees that looks suspiciously inaccurate. Yeah, there was this protractor debate early on when we were having our senior stream, right? And the answer is I have no idea anymore, because since the time when I was a student until now, it seems some school says no protractor and some school says never mind, bring in a protractor. And if you're reading the rules, it doesn't say anything. If you read the rules on the Math Society's website, it also doesn't say anything. So just follow what your school says. If you have a protractor, make the most of it. If you cannot, then that's unfortunate, but not much can be done about it. Anyway, the questions are not supposed to be solved by protractor, right? It's just that sometimes the schools seem to allow it. Okay, anyway, back to this. How do we make use of said information? Now, it is true that 80 degrees is half of 160 degrees. So, conceivably, they could be related in some way. But if you try to divide it, you realize that drawing an angle bisector is pretty weird. Not least because the diagram is pretty poor, but also it's quite weird because it doesn't really make full use of the equal lengths. Now, this is actually very similar to a question that I set previously, so I'm going to use the approach that I used in setting that previous problem. we notice that if we extend these out, and it is hitting the top of my screen, if we extend these out, this would be 100, this would be 20, again very much not to scale, but this top angle should be 60 degrees, which actually is somewhat to scale. Now with that 60 degrees down there, we would love it to be equilateral, but it is not equilateral. Nonetheless, we can draw another triangle next to it that is equilateral. So I'll mount an actual equilateral triangle next to it. And the good news is that once you mount this equilateral triangle, it is going to also be equal in length to all of these things here. Right? Because it is equal to BC, which is equal to everything else. We also have created a cyclic quadrilateral for ourselves. Because of the pair of 60-degree angles down there, we also have a cyclic quad. Now the rule of thumb for a geometry construction is that it needs to serve at least two purposes. Because you can always draw a line that serves one purpose. But if you draw a line that serves one purpose, I mean, that in itself isn't going to do anything. Right? Your line needs to at least serve two different purposes for it to be actually considered productive. Yeah. Now again, remember this is a horrible diagram, so none of the angles are going to look like what they appear. So be very mindful of that. Why don't we redraw it? Well, we can redraw it. I'm just trying to save a bit of time here, so I'll just stick to the given diagram. So this portion here is supposed to be 20 degrees. This portion is supposed to be 40 degrees. You see the problem, right? I said it's going to be horrible, and it really is. Okay, and yeah, just mark the 60 degrees here as well. And I'll call this point E and F. Now with all these equal lines, I want to find some congruent triangle somewhere, and what I can say is definitely going to be congruent is triangle ABE and triangle DCE. Okay, so those both are isosceles triangles with the 140 degree angle and the two equal lengths. So I'm going to draw in those extra lines now. And so this angle here, which is supposed to be 140 degrees, means that this angle here is 20 degrees. And this is now an isosceles triangle with a 60-degree angle at the top. So this turns out to be the world's worst equilateral triangle. Okay, so let me repeat that again. What did I conclude? I concluded that from this here, AE equals to DE, and the angle AED is 60 degrees. So it is equilateral. And so therefore, this angle down here, the remaining is 40 degrees, which is what you're supposed to find. And With that, let's take a quick 5-minute break here. If some of you or your friends are waiting for the later problems, just do invite them in. Usual YouTube stuff, do like the video, subscribe if you haven't already, and feel free to ask any questions during the break. I will respond after I'm back. Alright, let us continue with the next few problems. I think that one of the funny things about this year's paper is that there were easy questions, and a lot of the difficult questions are somewhat guessable, which is a bit unfortunate because it means that there are only a few questions that are both difficult and cannot be guessed. So by a combination of guessing and solving, you can really make quite a bit of headway. Yeah, fine. I should address all the questions on cutoffs for stuff. I said a bit about this earlier. Most of the time, the cutoffs for the honorable mention and bronze don't shift too much. Right? It's always somewhere about 6 to 7 for honorable mention, something like 8 to 10 for bronze. It is always going to be somewhere around there. And whether it's one more or one less depends on just like sort of the 7th or 8th or 9th easiest question. It also depends on the math society. Sometimes they decide to just round up and give a few more people the intended award. Sometimes they round down and give a few less people the award. So that's really their discretion. As to round 2 cutoffs, it is going to be traditionally somewhere about 12 or 13, and it can move up or down by a point. I know a lot of you are at that boundary, and that's the whole issue, right? Because a lot of you are at that boundary, so that's why the score is going to be around that boundary. And it is very hard to say for sure anything further than that. Gold cutoffs cannot really be addressed because that depends on the second round. Okay, so let's get back to these questions. We will go up to maybe question 17 or 18 and then take our next quick break. Okay, question 11. Right. Let ABC be integers with AB plus C equals to 49 and A plus BC equals to 50. Find the largest possible value of ABC. Now remember that this is an equation in integers. It's a Diophantine equation. Well, it's 2 Diophantine equations. So there isn't going to be sufficient information from an algebraic perspective to find out what ABC are. Right? There is not enough equations most of the time when you have something like this. You have to use the fact that they are integers in some clever way in order to hopefully get a factorization. Now, the first few things I will usually try are addition and subtraction. And it turns out that addition gives you something, but it's very messy. Subtraction gives you something nice. Because if you subtract, you get A plus BC minus AB minus C equals to 1. And this thing can be factorized out because there is a common factor of A minus C or C minus A. Now this is not how you solve equations normally if it's in real numbers. I mean, there's nothing wrong with doing this, but it doesn't give you anything concrete. But in integers, it gives you something extremely concrete because it means that either they're both 1 or they're both negative 1. So B equals to 2 or 0. Yeah, then we just check both. Right, if B equals to 2 and C minus A equals to 1, just put it back into the original equation. A would be 16, C would be 17. Obviously, then we don't need to check B equals to 0, right? Because that will not be larger. So the maximum would be 2 times 16 times 17, which is equals to 544. Thank goodness they didn't put a floor function here, otherwise I would have started to think it was a very strange inside joke. Question 12. Find the largest possible value of absolute value of A plus absolute value of B, where A and B are co-prime integers such that A over B is a solution of the equation below. If you look at this here, this is a nested square root expression. It is, common sense tells you that if you can't simplify that nested square root, there is no reasonable way to solve the question. So therefore, there should be a simple way to express this. And what I'm going to do is do a substitution. I don't want to use A and B to avoid confusion, so I'm letting y equals to square root x plus 1. And remember that this means y squared equals to x plus 1. I'm also going to use that to substitute the parts with x without the square root. Okay, so this one becomes 4y squared plus 1 minus 4y. This becomes y squared plus 1 minus 2y. And lo and behold, we get two things which are actually perfect squares. Now, in theory, you could have done this without the substitution, but it is just way harder to spot. So this is nice because, well, it's a square root of a square, but don't be too happy, right? Remember to leave the absolute value in. And when it says largest possible value, there's a hint at it shouldn't just be one solution. So you get this. Okay, so now we just need to solve this. And we can split it by the different parts of the number line. If y is greater than or equal to 1, then both of these are positive. You get 3y minus 2 equals to 1. So y equals to 1. And if y equals to 1, x is 0. So if x equals to 0, that is most certainly not going to be the largest solution. So the next case is if it's half to 1. Sorry about this. If it's from half to 1, then it becomes 1 minus 2y. It's 2y minus 1 plus 1 minus y. Equals to 1, and this gives you y equals to 1 again. So that's no better. Sorry about this. I hope it was resolved after a while. And this time it doesn't give any difference, so we will abort it and just check the last case when both of them are negative. Okay, if this continues, I'll just pause a while to restart the program, because it does happen a while when I have my mirror open for too long. Okay, so y equals to 1/3 and x equals to negative 8 over 9. Yeah, so that's the largest value. The largest value is 8 plus 9 is 17. Question 13. Let S be the set of real solutions of the following system of equations. And there's this strange looking answer abstraction. For each x, y, z, define m of xyz to be 2000 absolute value of x plus absolute value of y plus absolute value of z, determine the maximum value of mxyz. So it basically means find the solution with the largest sum of magnitudes. Put in a nutshell. Now the first thing that we can say about magnitudes is that with the 4x squared over 1 plus x squared, 4y squared over 1 plus 4y squared, and 4z squared over 1 plus 4z squared, technically this is pretty redundant because it's going to be positive for sure. And not only is it going to be positive, it is going to be between 0 and 1. Right, so I mean, we can say this pretty easily from the terms on the left hand side. They are all going to be between 0 and 1. So you don't really have to worry too much about the absolute values there. This question is more of, can we find the solutions? Now when I saw 4x squared over 1 plus 4x squared, it felt a little bit artificial because I mean, there is the potential trigo sub, but it doesn't do any good. So it makes more sense to take the reciprocal of everything. So 1 plus 1 over 4x squared equals to 1 over y. And likewise for the other two equations defined in a cyclic manner. Yeah. Now, some of you can already see this. Yeah, x equals to y equals to z does work. Some of you can already see that this would be fine, but in order to actually show that this turns out to be what we think, if you can't deal with this, we can do a further substitution of a equals to 1 over 2x, b equals to 1 over 2y, and c equals to 1 over 2z. Now once you do that, it's going to be a lot more obvious what's happening. Right, this is what you would get. And we see that there's the 1 plus a squared and 2a, 1 plus b squared and 2b, 1 plus c squared and 2c. So if you sum all of them up, then you are going to, either by AMGM or just by grouping together, you're basically getting equivalent to a minus 1 squared plus b minus 1 squared plus c minus 1 squared equals to 0. Yeah, so a equals to b equals to c equals to 1, and that means that x equals to y equals to z equals to half. Now I know I threw away the solution 0, 0, 0 in coming from here, right? When I took the reciprocal, there is the 0, 0, 0, but that is not going to be relevant to the maximum, so I just didn't worry too much about that. Okay, so your answer is 2000 times of half plus half plus half, that is 3000. Yeah, the xyz are between 0 and 1 is just an observation. It's not really essential to what we're doing. I'm just pointing out that because all the rational expressions on the left hand side are all positive, but they also are less than 1 because the numerator is strictly less than the denominator. So because of that, we don't really have to worry too much about negatives, and also when I'm using my inequalities or any bounding, it doesn't really matter. Yeah, but it's not really essential to the rest of the solution, so you don't have to worry too much about it. Yeah, and the substitutions are just for easier observation of what's going on. Yeah, I was saying about easy to guess, right? So this is one of those questions where if you guess x equals to y equals to z equals to half, that's the first thing I did, right? When I saw this question, I was wondering, that's probably the biggest, right? And then since I'm explaining it here, I did spend a bit of time to figure out why, but it is quite intuitively true that they all should be half. Okay, question 14. This is quite an interesting question, I would say. The value of t to the 4 minus t cubed minus t plus 10 doesn't really seem very illuminating. And if you tried to so-called unwind all the square roots, so you square, then minus 1, and then you square, and then minus 1, and then square, and then minus 1, and you square, and then minus 1, it doesn't seem to be doing a whole lot of good. Now, what I want to think of this as is, I'll define the function fx equals to square root 1 plus x. Because that's the thing that is being done basically 4 times. Now this equation then becomes t is equal to f of f of f of f of t. And this is what it becomes. Now when I saw this, I was pretty sure that shouldn't this mean that f of t should be t? Isn't it supposed to be a fixed point? So from a SMO perspective, we have found one solution, right? So that one solution is good enough. If we find f of t equals to t, then we know where to look. Right, so t squared minus t is 1. And so that means t to the 4 minus t cubed equals to t squared. So this is equal to t squared minus t plus 10. And t squared minus t is 1. So it's 11. Yeah, so this feels like it is cheating a little bit. But this is what we call a fixed point of the function. Now, if we took anything larger than this, it is going to remain larger than this because f is an increasing function. So if you had, right, so if t were larger, then your f of t would be more than t, and so would f of t. So it will just keep getting bigger. And likewise, if f is smaller, then it's going to get smaller and smaller and smaller, right? So this is more or less what it is going to imply, right? You're going to keep on going under or keep on going over. So this is the only value in which it will hit it on the nose. But the intuition is there, right? The intuition is that if you can find a fixed point, it's bound to work. If you want to be a bit more rigorous, you can say that if I took anything beyond the fixed point, it is just going to get further and further away. If I took anything below the fixed point, it is also going to not get there. Okay, so that's the idea if you want to be a little bit more rigorous. Yeah, there's a lot of unfortunate ways in which these sorts of things can go wrong, so do be careful. Okay, question 15. In the triangle ABC shown in the diagram below, the external angle bisectors B and C meet at the point D. For those of you in the know, you know the external angle bisectors intersect at the x-center. So this is actually the x-center opposite point A. If you have no idea what the x-center is, it is the center of the circle that touches the side BC and the extensions of the other two sides. But it doesn't actually matter here very much. Just want to sort of mention is the x-center. Now you draw a tangent to the in circle. So if you draw a tangent, you always need to draw in the center, right? And the center is the in center. The moment we see this, it is important to note that the external angle bisectors, by definition, are always perpendicular to the internal angle bisectors, which must go through the point I, the in center. So you get more right angles. And if you have a glut of right angles, you know that you are bound to get a cyclic quadrilateral. In this case, all the 5 points are concyclic. They're all concyclic with IA being the diameter of that circle. But that's not so important. The concyclic is more important. Now, angle BEC is equal to 112. Because of the cyclic quad, it means that angle BIC is also 112. And these are angle bisectors. So if they're angle bisectors and this is 112, it means that these angles sum up to 68 degrees, and your angle A is just 180 minus 2 times of that. Which is 44 degrees. Yeah, so external or exterior angle bisectors, it's called that because it bisects the exterior angle. But if you look at the internal and external angle bisectors, then they collectively split up the straight line 180 degrees into half, right? So the angle between them must be 90 degrees. And that is also an equivalent characterization of an external angle bisector. It is just perpendicular to the internal angle bisector. So we can use those right angles to give us the cyclic quad. Okay, question 16. Find the largest integer n such that n squared plus 5n minus 9486 equals to 10 times s of n. I don't know why they use s for product. It's weird, right? But s of n is the product of all digits of n in the decimal representation of n. Decimal just means base 10. So it just means the normal digit interpretation, not binary or something else. Yeah, this is weird notation, s of n, but otherwise it is also a strange question, because what does the product of digits of n have to do with anything anyway? And whenever you get a strange looking insertion into the question, whether it be the floor, the fractional part, the number of zeros, or something funny like that, one good practice is just to ask yourself, how big or how small is it going to be? To give yourself a sense of how much impact does it have on the equation. Now, for example, if you have just something like a sine or cosine, a sine or cosine is always between -1 and 1. So even if it doesn't seem to belong there, in terms of magnitude, it doesn't affect very much. So here, in terms of the magnitude, it also doesn't affect very much. The reason why it doesn't affect very much is that the product of the digits is always going to be less than or equal to the number itself. The reason is that every place value in the number, every digit is worth 10 at least. And the digits are at most 9. So this is going to be true. Equality is only if it is a 1-digit number. Now, therefore, it simply means that your Sn is not going to be very big. So it gives you a sense of roughly what's going to happen. Now, on one hand, we can therefore say that this is going to be less than or equals to 10n. On the other hand, it has to be greater than or equals to 0, right? Because the product of digits is non-negative. So we get something like this. Now we can see from this equation here that if your n is 100 or more, then if n is 100, it would be 9500 minus 9486. That's positive. So n has to be less than 100. Now from here, you can tell that, well, it can't be too small either, because if n is, let's say, 90 down here, 90 is still going to be too small. 8100 plus 450 is too small. So n is more than 90. So it's just going to be 90 something. Now at this point, it is completely up to you how you want to go about this with the 90 something. You can either go with I'm going to try cases, or you can go with I'm just going to start from like 91 or start from 99 and check all of them. If you want to expedite things a little bit, what I can say, since n is going to be 90 something, means that Sn is divisible by 9. Sn is divisible by 9. 9486 is also divisible by 9. So therefore, n squared plus 5n should be divisible by 9. So that can sort of trim your search space a little bit. Right, so if n divides n plus 5, and it is 90 something, it can't be 90 as we have established, so the only things to check is 94 or 99. Right, and it turns out that 99 will work, so there's no need to check 94 because that's the larger one. Yeah, I just wanted to mention that there is a way to trim it a little bit before we do the search, but I know some of you just try, hey, does 99 work? Oh, it works, hooray. That is very reasonable as well, and it is fine. Yeah, last digit is also okay, right? That is true. So you can use the last digit to do some filtering. But yeah, I think this is a little bit more refined. Having said that, it doesn't matter, right? As long as you get to the point where it's just a few cases, things are good enough. Okay, so one or two more, and we shall have our second break. Question 17. Right, find the number of integer solutions to the equation 19x plus 93y equals to 4xy. I was absolutely convinced this must have come from the year 1993, but I did not find it. It's not a difficult question, but I thought it was lifted off because occasionally that does happen in the SMO. It's lifted off from some very, very old competition. Maybe it was, but I didn't see it around anyway. The idea is still going to be very similar for most of these questions, which are with something xy, something x, and something y. I'll move everything over first to one side. Remember, it's integer solutions. Otherwise, it would just be infinitely many for real numbers. Now, what we can do here is, so in the US, they call this Simon's favorite factorizing trick. Over here, for me, in my lessons, I like to call it completing the factorization. And completing the factorization is an allusion to how we complete the square. Right? Because we would like to factorize it, but it is not quite factorizable because there is one term left over. So I say, never mind. I still want to factorize out the same factor 4y minus 19 from behind. So I'm going to do that anyway, even though it isn't actually possible in a strict sense of the word. I'm still going to factorize out 4y minus 19. And I borrowed 93 times 19 over 4, so I need to return it back. Okay, I'm going to multiply everything by 4 first before we proceed. And then we will have a factorization at the end of this. Okay, so I'll move this over. 93 times 19 equals to 4x minus 93, 4y minus 19. There we go. Right, this is a factorization where we have just borrowed a constant, just like completing the square. We don't really worry too much about constants. Right? We just take whatever we need in order to complete our factorization. Now, integer solutions. This one is a very finicky kind of issue because you need to be careful with your positives and negatives. Right? This is something where you need to be careful. Also, that you can actually reach those values. Right? Like, can the 4x minus 93 and the 4y minus 19 actually make it there? So 93 times 19, you factorize, you've got 3 times 19 times 31. There are 8 factors of this, which for the first time in a long time, I'm actually going to just write out in full. I know this is a very old-fashioned way to do it, but there's only 4 pairs, so I want to make my point clear. Now, these are for the positives. And we need to know whether they can fit in one way or they can fit in 2 ways. Now, one way to do it is just to check all of them, right? Just to plug it in. But the only thing we need in order for 4x minus 93 to be this value is that this is actually going to be 3 mod 4. And this one is going to be 1 mod 4. Right? Negative 93 is 3 mod 4, negative 19 is 1 mod 4. Now, because in each of these cases, this product here is going to be 3 mod 4. And the only way that your product is 3 mod 4 is one of the factors will be 1, one of the factors will be 3 modulo 4. It cannot be even, it cannot be both 1, it cannot be both 3. So it will always be that one of them is going to fit. So you will get one particular ordering in each of these will be valid, one ordering will not be valid. So you have 4 solutions here. But another 4 for the negative case, because they are integer solutions, not necessarily positive integers. Because of the plus or minus. And in the plus or minus, they're still going to give you one of them being 1 mod 4, one of them being 3 mod 4, right? Modular arithmetic still continues into the negatives. So you do end up with 8 solutions. Okay, question 18, and then we'll take our second short break. If you know of anyone that's just waiting for the last few questions, feel free to invite them in a little while if that is something that you think will be helpful for them, because there are some interesting questions at the back, along with some not so interesting questions at the back. Okay, question 18. Find the number of integer solutions to the equation x1 plus x2 minus x3 equals to 20, with x1 greater than or equal to x2, greater than or equals to x3, greater than or equals to 0. Now, 20 is actually pretty small, which means that you can list. You can list as long as there is some sort of a bound available to you. As long as you know that there's some sort of bound, then we are okay. Now, you can either use the bound on x1 or on x2 or on x3, whichever one you want to bound is fine. But if let's say that we have a very quick stare at this, we know that x2 minus x3 is greater than or equals to 0. It is non-negative. And so therefore your x1 has to be less than or equal to 20. Now, technically, that's already enough, right? As long as you know that they are bounded. If x1 is less than or equals to 20, everything is less than or equals to 20. Then you can split by cases already, and you can split by cases for x1, for x2, or x3. All are okay, And in fact, I've seen solutions using all three ways to split. Now, for some reason, the first thing I did was split by x3. So I'm going to show that, but if you split by x1 or split by x2, they're all comparable in terms of the amount of effort, so it doesn't matter too much. And if there's some clever bijection, which I don't know of, feel free to share, but I think it is going to take me longer to think of the bijection than to list cases, so I shall list cases. Okay, so I split by x3. If it's 0, then your x1, x2 sum to 20, and x1 is more than x2. So it goes from 20, 0, all the way to 10, 10. Okay, there are 11 solutions here. If it is 1, then the other two sum to 21, but the smaller value must be at least 1. So it goes from 21 all the way to 11, 10. Now you have 10 solutions. If we start at 2, you can always start from 20, right? This is always a given. You can always have 20. And this time, they have to sum to 22. So it goes until 11. And you still have 10 solutions. So you just continue, right? And this is not the most inspired solution, but it also works. So whether it works is the more important thing, isn't it? Yeah, so each time you see it just takes a step up, a step up, step up, and each time you take a step up down here, you have one less possibility. So you're going to get 10, 10, 9, 9, 8, 8, all the way until the limit. The limit would be if they are all 20. Right? If it's 20, then there's only one way, which is 20, 20. The one before that, which I usually write the one before that so that I don't get off by 1 errors. Right? So I want to make sure that I don't miss the last case. So I will always check around it. If it's 21, you know that it doesn't work anymore, because then the other two will sum up to more than 41. If it is 19, these two sum to 39, so you can have 20 and 19, there's still one case. Right? So it becomes your sum, the number of solutions, is 2 times of 1 plus 2 until 10 plus 11, which is equal to 121. Yeah, so there's a whole lot of different ways in which you can split cases. But as long as the SMO open question can be done by splitting cases like this, I think we should just accept it. No need to find a more elegant solution. This is really great already. Okay, and with that, let's take our next break just for 5 minutes. If you have any questions, just feel free to share and discuss it before I'm back in a few moments. Yeah, I think it's true that this year's paper, I think I mentioned at the start, right? This year's paper is kind of filled with questions where if you know what to do, the solution is not that long. So in theory, if you are going in the right direction, you will feel less time pressed than last year's paper. Right? That's I guess how I can put it. If you are going in the right direction, if you go with very long-winded methods that are not intended, then of course any question could take really long. Okay, so let's finally go through the last set of problems. Now, the last set of problems are the ones that I saw most recently, almost just like about 45 minutes before this stream started. So it is the most likely that I have a solution that is not ideal. So feel free to share if you think there is a better solution than whatever I can propose. Okay, question 19. The diagram below E is a point outside the square such that CE is parallel to BD. Oh, it's already marked there, isn't it? Never mind. CE is parallel to BD and BE is equal to BD. So you've got these equal lengths, but as they're telling the equal lengths, in the next breath they tell you, oh, by the way, it is equal to square root 6 plus square root 2. So these two lengths are equal to square root 6 plus square root 2, but with that you kind of can find everything except the thing that you're asked to find. These are both square root 6 plus square root 2, but square root 6 plus square root 2 is the diagonal of the square. So it means that the ratio is 1 is to 1 is to square root 2. If you divide by square root 2, it means the side length of the square is square root 3 plus 1. And that's the point at which you realize this is a very horrible question. It's a horrible question because if the answer is an integer, surely it must be 2, right? Square root 3 plus 1 is 2.7. So I mean, this can't be 1. So it must be 2. Just by scale, it is very obvious that it is more than 1. So it is a very unfortunate case of SMO blindness that happens once in a while. Don't worry, I'm going to explain it properly. So I'm not going to stop at it must obviously be 2. But if you're taking the SMO, please stop at it must obviously be 2. Don't waste any more time and just move on. Okay, so now how do we do this if we are not going with the it must obviously be 2? Well, I want to use the parallel line. And the parallel line can give me similar triangles, but the similar triangles don't seem that useful yet. So the alternative use would be in terms of angles. Right, in terms of angles, this is 45 degrees. So this angle here is 135. So that means I can use the sine rule to find out this angle. Right, because it means that root 6 plus 2 over root 3 plus 1, I'll call this theta, is equal to sine 135 over sine theta. This is square root 2. This is square root 2 over 2. So that means sine theta is half. And theta is 30 degrees. Now that's great, because if this is 30 degrees, then it means that this is also 30 degrees. Yeah, some of you probably know what is the... Yeah, this is 105 degrees, right? So some of you probably already know what is the sine and cosine of all of these. You can either use the sine rule if you know sine 105 degrees or feel like using the identity, or if you want to use the cosine rule, that is going to be a little bit more problematic because you will need to solve it in terms of x. So I'll just use the sine rule on triangle BDH. Over sine 105 equals to dh over sine 30. I'll just mention that sine 105 degrees by using the either 60 plus 45 or 135 minus 30 or whatever you like is just going to be root 6 plus root 2 over 4. Right? Any multiple of 15 can always be reached using your identities and special angles. So because of that, it means that literally this is 4 equals to 2 dh and dh equals to 2. I think no one was interested in that because the moment I said it must obviously be 2, everyone just decided to take a mental break. But it does make sense, right? For the SMO, it is 2 for the purposes of understanding it, and for anyone who's watching this review a half year later, yeah, it's just good to mention the proper approach. Okay. Next up, question 20. And this is the parabola that I mentioned is going to be a lot nicer than the parabola I was trying to draw in the earlier problem, which was question number 4. Yeah, this is a much nicer parabola, but this is not how the circle is supposed to be for that question. For that question, it's supposed to intersect it more times, but this is supposed to only be touching. Which also begs the question, why is the Singapore Math Society setting 2 questions with almost the exact same idea? And the answer is I'm not really sure, but it happened in the senior as well, right? There were 2 questions that were just about completing the square using either sine or cosine, and now yeah, basically you have got more questions like this on discriminant or discriminant adjacent stuff again. Well, let's make use of the fact that it's just discriminant adjacent stuff to see what we can do. First of all, we have one circle that is supposed to be down here. Now, the circle that is as large as possible should only have one point of intersection. Otherwise, it means that, yeah, I mean, you have exceeded the bound. So we want to know how far we can go such that it only touches it once. So let's call the radius, the first radius, R. I'll call it R1 maybe, just because capital R is already taken, and I want to call the other one R2. So I'll call this R1. Now, the equation of the first circle is x squared plus y minus R1 squared equals to R1 squared. I can substitute in x squared equals to 2y, and this is really awkwardly familiar. The R1 squared cancels out on both sides. So y squared plus 2 minus 2 R1 y equals to 0 should only have one solution. And clearly y equals to 0 is always going to be a solution. So in order not to end up with any other solution, well, we can go all the way up to R1 is equal to 1. Yeah, so just like the earlier question, right? If you were here at the very start, why is it that why can't R1 be something like 0.5? Well, it can be. If R1 is 0.5, that's not the smallest. If you're wondering, why can't R1 be bigger than that? Well, if it's bigger than that, there will be multiple solutions. So we cannot accept that. Multiple positive solutions, I should say. Okay, so now we know that this radius is actually 1. And that's why the additional constant of half down there was meant to cause this to happen. Okay, so this is 1. The diameter is now 2. And we shall move on to the upper circle. By symmetry, we still know that the center of the second circle is on the y-axis. And let's say that this radius is now R2. Yeah, if there's any of you who know some method using conic sections, feel free. Right? It's just that I think there's no need for that here. So rather than think of a clever property, if you know an obvious solution, use the obvious solution. Yeah, your second circle. This time, the center is going to be at 2 plus R2. And the radius is still going to be R2 squared. Once again, substitute in x squared equals to 2y. And this time it is a little bit less trivial than the other one, but we can still write it out anyway. So again, the discriminant here is supposed to be equal to 0, so that it touches exactly once. So the discriminant but we don't have to expand this because there is a common factor of this R2 plus 1. And obviously R2 plus 1 is not going to be 0. The radius is not negative 1. Otherwise, that means that it's just repeating the same circle below. Okay, so R2 would be equal to 3. Right, because you can't have R2 be negative 1. No, other value is 3. So then 1 plus 3 equals to 4 will be the sum of the two radii. Yeah, remember I was saying earlier on about a scale, right? Some of you guys talking about using a ruler. There are some questions where there are no way to draw it not to scale, unless it is obviously wrong. So for example, for this question, it is pretty impossible to not draw it to scale. So you can use that to get some intuition. If let's say you know that the smaller one is 1, how is the bigger one going to look? Of course, you are hoping that the curvature of the parabola here doesn't matter too much. At least that's what you're hoping for. But I think that is, if you really don't know what to do, that is a reasonable assumption. Okay, and on to the first question that is a little bit more unusual. This is the alluded to Pell's equation from just now. Having said that, if you had sufficient persistence, some of you may have actually found out the solutions for x and y without using Pell's equation. Just that it will take a while. It turns out that you need to wait all the way until x is equal to 30. Now the problem is not that it's 30, the problem is you don't know it's 30, right? So if you say you started listing, many of you may have given up at 10 or 12 or 15 or 18. I mean, there's no reason why you will keep going on and on and on and on and on. So it is not something where you can say, oh, I should have just listed till 30. If you try listing every single question, surely there will be some of them that you'll give up on, and you may also run out of time for some stuff. So it is, in this case, not something I will call guessable, even though the number is relatively small. So if let's say you tried 1, 2, 3, 4, 5, 6 or something, you would realize that, okay, there isn't really going anywhere. What do I do next? What I'm going to do here is I am going to complete the square. And completing the square in progress. Now sinking in progress. Okay. And I will multiply in stuff very shortly. I'll take out the 1/6 squared. I'll take out the 1/8 squared. Software is more exhausted than me. It's taking longer and longer, isn't it? Okay. I guess we should finish quickly before things get out of hand. And I'll just multiply everything by 48, which is the LCM, to clear everything. Now, if we rearrange this, this will be in the form of a Pell's equation. So multiply the 4 in as 2 squared. You get something squared minus a constant times something else squared equals to 1. So Pell's equation is whenever you have something in this form, x squared minus dy squared equals to 1. This is known as Pell's equation. D is some constant, any constant you like. So you get it into that form, then if you know what is Pell's equation, then you win. If you don't know what's Pell's equation, then of course you probably would have stopped even long before this. So for Pell's equation, how it works is that you find the smallest equation, for smallest solution. Let's say AB. And then after that, all of your solutions are going to be in the form a plus b root d to the power of n is going to be equal to an plus bn root d when expanded. And this would be the sequence of solutions. This is just the theory of Pell's equation, and you are more than welcome to check out more details on it. I can't really summarize it in the course of this review. So let's apply it to our example. So you know what it means, and you at least have a visual understanding of, okay, this is what it means by the approach to solving Pell's equation. Now we will solve the equation first, just as x squared minus 3y squared equals to 1, and we'll see whether the values will fit in there. Now the smallest solution is obviously going to be 2, 1. Now we call this the fundamental solution. The smallest solution is the fundamental solution. And once you have found that, what you're supposed to do is to take 2 plus square root of 3 and take powers of it in order to see whether it works. Now you might say, hang on a second, why can't we just use 2, 1? Well, if you use 2, 1, that corresponds to x equals to y equals to 0. Well, we knew that would work, but that's not the one we want. We want positive integers. So if we square it, you get 7 plus 4 root 3. And so the next solution is going to be 7, 4. But 7, 4 is not in this form. So we continue again. Multiply in 2 plus square root 3. So you get 14 plus 12 is 26. 7 plus 8 is 15 root 3. Now this does not work. So continue some more. Yeah, and this is unfortunately how it has to go, right? You're going to take a little bit of time to get through all of these until we finally find the thing that works. So 52 plus 45 is 97. 26 plus 30 is 56. Now all of these pairs, 26, 15 is a solution. 97, 56 is a solution. So all solutions, it's just that they don't fit into 12x plus 2 and 8y plus 1. So that's why we have to continue. It's going to take not much longer. How do we know this is going to end? We don't, but we just trust it is going to. Now, in this case, you can be very grateful because it pretty much ends here. Okay, now this one actually works. So it corresponds to x equals to 30, y equals to 26. And there was one Pell's equation question in the SMO senior about 2 or 3 years ago, and this is the next one. It's funny because the Pell's equations question have never ever shown up. I learned it while I was in the senior team for the first time as a student, and I don't think I've seen a question about Pell's equation in the SMO all the way until a couple of years ago in the senior paper, and now here. So maybe it's about time that we all learn Pell's equation a little bit better. But it is not something that is well known yet, and it's also not something that is frequently asked. But it is pretty important in number theory in general. So some of you may be surprised to know that Pell's equation is related to continued fractions. You know, the weird questions you have in primary school of rewrite this as a stack of fractions, that continued fraction. Pell's equation is very related to continued fractions, and there's very rich theory down there. If some of you are looking for some project to do for SMPF or something, you can actually do that. Okay, 22. Yeah, a group of students participate in some sports activities among 6 different types of sports. It is known that for each sports activity, there are exactly 100 students in the group participating in it, and the union of all the sports activities participated by any 2 students is not the entire set of 6 sports activities. Determine the minimum number of students in the group. Okay, let's try to understand this. There are 6 different types of sports, so you can think of it as in the 6 different types of sports, let's number it 1 to 6. There are 100 vacancies in each of them. I'll just say 100 slots available. Now each student takes part in some sports, but any 2 students collectively do not participate in all 6 sports. So it means you cannot find a pair of them in which, let's say, the first student does 1, 2, 3, 4, the next student does 5 and 6. You cannot have that. You cannot have the first student does 1, 3, 5, second student does 2, 3, 4, 5, 6. You cannot have that. Determine the minimum number of students in the group is in a way asking you to try to fill up this 100 slots per sport using as few students as possible. So what I want to know is how many students can I actually get? So how many sports can I get a single student to participate in? So let's see. Right. So for a single student. Now if I have that one student, I want students to participate in lots of sports. Now I sound like the Ministry of Education. No, in the question, I want as many students to participate in as many sports as possible. I want to know what's the upper limit. Now, one student cannot participate in all 6 because then they plus anyone else obviously cover all 6. Now, if let's say they do 5, and let's assume that they participate in 1, 2, 3, 4, and 5. Now, that means that no one can participate in sport number 6. Because otherwise, this student plus that guy is going to have the union be everything. So no one can do 6. So this is also not going to work. So we are getting warmer, right? Because obviously the worst possible answer is that, okay, everyone just takes one spot. Everyone does one spot, or everyone does 2 spots. Then if everyone does 2 spots, you would take 300 students, right? And we want to know whether we can do better than that. So for 4 spots, let's say that you do 1, 2, 3, 4. Right? It doesn't matter which spots. I mean, the numbers are just for convenience. Now that means that for your spot number 5 and spot number 6, you will need to make sure that no matter how, no one does both 5 and 6. So if nobody does both 5 and 6, then it simply means that, well, the 5 and 6 the slots, each slot has to be taken up by a different student. So you need at least 200 students to fill the slots for 5 and 6. Now, is that possible or not? I mean, a bit of a spoiler, right? Because when you see this, you realize that maybe it's better to evenly distribute. Because this is wasting a lot of slots where you say, okay, these two, no one can ever do both of them. Isn't that kind of a waste? So it means you need at least 201 students. And I'm going to pause this here. I'm pausing this here because I already know the solution. But also because if, let's say, I were doing the question here, I would want to say, this doesn't seem very optimal. Can I do better if I don't include this? If it doesn't seem that I can, then I'll come back to here again. For most of these kinds of combi questions where you're looking for a construction, the construction is usually very nice and very symmetric and very regular most of the time. So if you get something that feels very ad hoc, like very strange, it's probably wrong, because how are you going to come up with an ad hoc construction for 100 slots in 6 spots? It sounds like a very bad idea, right? Now, if we don't have 4 and we do a maximum of 3, now we know that if they're all 2, then you could have just go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and that would take 300 students. So I want to know if just I look at groups of 3. Now 3 and 3, there is a small risk that you will end up with an overlap. You end up with no overlap, I should say. If you have no overlap, let's say someone does 1, 2, 3, another one does 4, 5, 6, then the union would cover everything. So there is a small risk, but not as bad as 4. So we can try to construct. Is there a way that I can have no non-overlapping pair of 3s? The first one I can do is just 1, 2, 3 because it doesn't matter. I have to overlap something. So let's say I overlap 1. And I do 4 and 5. I need to cover 6 somehow, and I cannot keep on going with 1. So if I want to cover 6, I can do 2, 4, 6. And then now, if let's say I want a different combination, I can cover 3, 5, 6. And this is a very nice configuration that fills up 2 slots for each spot in 4 students. So 4 students filling up 2 slots each. And because they all have 2 slots filled for each spot, rather. And because there is no overlap and it's 2 each, we can just repeat this. So we can get 4 times 50 equals to 200. Obviously, if I use 3s, I cannot do better than this, right? Because each student fills up 3 slots. So 200 is the best case scenario if I only use 3. And if I use 4, I've just shown that I need more than 200. So therefore, I know that this has to be the answer. This is the best. Yeah, so this is the sort of question where if any of you are watching and you are doing, let's say, senior, this could be a senior round 2 kind of question, except that they won't give you something as small as 6 and 100. It'll probably be something like M and N, or maybe it will be something a lot bigger than that, so that it won't be just such a simple construction. But this is the sort of thing that is going to be like a senior round 2 question, if you give a full proof, that is. I think this is a bit too easy to be an open round 2 question, right? It's an open round 1 question. Okay, 23. We are getting there. And 23 is one that annoyed me a lot because I couldn't find a simple way to do it. And I still don't know a simple way to do it, but the cheapest way to do it just works. Now, technically, it is a sound argument. It's just not very satisfying, right? And all I can suggest for now is to do what most of you did. But before I get to that, right, the intuition here is that this power 9 is just really, 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 really strange. It does not factorize, it does not give you any identities, and it makes the thing on the right really, really big. Right? You're taking power 9. You take 5 to the power of 9, that's already a little bit annoying to calculate. If you take 7 to the power of 9, that is really annoying to calculate, and anything beyond that is just kind of absurd. Now, it would fit P within the scope of your SMO answer, because here there's a P cubed. So P cubed versus Q to the 9 means P is roughly on the order of Q cubed. So if Q is something like 11 and P is something in the thousands, that's still going to be theoretically within the limit, but it just does not seem like the sort of thing that you are supposed to be calculating. So since they asked for the smallest value of P, the simplest way to go, as many of you did, is just to try the small values of Q. And well, hope for the best. Now, a little bit of additional computational help. We can just factorize a little bit. Here's a factor of P, here's a factor of Q. We can take them out. Yeah, the 18, you cannot factorize this. P squared minus 5P minus 18 is not factorizable. So we can try the small values of Q. There's nothing more I can suggest than that. Now, it's pretty clear that as Q gets larger, the right-hand side is increasing, and the left-hand side is also an increasing function. You can differentiate if you really want to track that, but it's not very necessary. So it's going to be increasing, meaning that your P is going to get larger if the right-hand side is larger, so we want small values of Q all the same. So if Q equals to 2, I'll just put it down here. It's a bit easier to see than to just jump in what is P, so that's why I write it like this. 256 minus 7 is 249. 249, as far as I can tell, is prime, unless I am missing something very obvious. I do not think so. Now that means that either P is 2, which is obviously absurd, or P is 249, which is equally absurd. So it definitely does not work, and I don't need to keep on plonking values of P inside. Okay, so let's try Q equals to 3. I'm not very proud of this solution, but it's just possible that that is what's intended. If you try my mock paper, I mentioned 1 or 2 so-called garbage questions, meaning that they're just there to occupy your time. There's no clever way to do it. You just have to do like guess and check, estimation and bounding, and it works. The SMO likes to have 1 or 2 of such questions. 3 times 8, oh my gosh, I did not realize it divides by 3. Okay, that is very embarrassing. However, it does not really change things that much. So, yeah, this is and this is something that happened to me before. When I was looking at last year's SMO second round paper, the final question with the 2049, I spent about 30 minutes thinking 2049 is prime, because I started testing from 7 and I did not check 3. So thanks for pointing that out. Now 2049, this is 249. The same thing happened to me again. However, it doesn't matter, right? 2 doesn't work, 3 doesn't work, and 83 obviously doesn't work, so we are still okay. Yeah, so now for 3, you get 3 times, oh boy, what is this? This is 3 to the 8 is 9 to the 4 is 81 squared is 6561. 6561 minus 7 is 6554. This is divisible by 3. Am I counting? No, it's not divisible by 3. Gosh, I've taken leave of my computational senses. And 3277 is not prime. I know I checked that, right? Because in the final answer, it does matter. Right? I'm just quickly running through factorizations in my head. And yeah, I think there is nothing else. Yeah, there's nothing else. Yeah, and you know that, as mentioned, P is on the order of Q cubed, roughly. So you can try P equals to 29, and P equals to 29 does work. So it works, and that is the thing that we take. I'm still not satisfied with this, but I don't really know an alternative. I mean, going back to the same idea as many of the previous problems, right? When you're doing the SMO open, if you find a simple solution, just find a simple solution. Yeah, this is the sort of question that, I mean, I don't like it as a question, but there's no simple way to tell. Just, you just run through all the factors one by one and try to factorize it. There's nothing else that can be done as far as I can tell. Feel free to correct me if you know there's a better solution. I just have not thought of any in the brief period I had before this live stream. Okay, 24. I know that Dr. Lee Chanlai, he has his YouTube channel with a lot of inequalities questions, and I'm quite sure he has one question something like this. Maybe not with 2, 3, and 4. At the same time, many of you would have guessed that A, B, C should be 2, 3, and 4 because it just seems very tempting, right? It seems very, very tempting, and it turns out to be quite right. How you do this is that for a squared b cubed and c to the 4, if you were to just use classic AMGM, right, that will give you the maximum value of a, b, c. Because that would be, if a, b, and c are all the same, then a times b times c is going to be as large as possible. If you want a squared, b cubed, c to the 4 to be as large as possible, you want to make sure that this thing has 2 a's, 3 b's, and 4 c's, and you want those things to be all equal to make the product as large as possible. So on that note, I'm going to write it like this. I have 2 a's, 3 b's, and 4 c's. Now this feels very like cheating, right? Now we have a ban on chicken, right? Imagine if you ask for a double portion of chicken and they gave you 2 half-size plates and say there are now 2 plates of chicken. Now that is nonsense. But for AMGM, we are allowed to literally say that now I have 2 a's, even though they're both half a, because we are about to multiply them anyway. So I can say that the maximum product of all of these nine terms happens when they're all equal. That's what AMGM is saying, right? And I think sometimes it's easier to see the intuition than to just chuck things inside. It's when they're all equal to 1. Right? There are 9 terms here, equal to 9. So the maximum is 1. And so therefore a squared b cubed c to the 4 is really less than or equal to 2 squared times 3 cubed times 4 to the 4. Right? Equality holds when a is 2, b is 3, c is 4, but that is also very clear. Yeah, and again, calculation. This is not a lot of fun, but the value that I have is 27648. Hope that's right. Last question, and we are here a lot earlier than I anticipated. As I said, there were many questions here which have short but non-obvious solutions, and furthermore can be guessed moderately easily. Now, I'm not going to be saying things like that for round 2, right? If we are working on round 2, I won't keep saying guess, 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 but in practical terms, 2.5 hours is not a lot of time to solve each question as is intended or as is printed in the solution book. So you have to take shortcuts here and there. It can't be helped. Question 25 is the first time in a while that you have a functional equation in the SMO open that is not actually easy to guess the function. It's not very easy to guess the function. Doesn't mean the function is very complicated. The function is not very complicated. It's just not very obvious what it is by staring. It's not very obvious what it is. Now, it turns out that the function is just going to be x plus 1 over x, but that's not very obvious compared to some things that we have seen before. Sorry, I mean 1 plus 1 over x, yes, not x plus 1 over x. Still not very obvious, right, that this is what actually happens. So how do we do this? Now my intuition is that the form that they give it to us in is very uncooperative. It doesn't seem very nice. I'm sure this is not the best way in which you can express things. I can't say which is the best way, but this is just very clumsy looking, right? With so many factors. So I'm going to just divide over the x, y, fx first. I'm not objecting the fraction since I'm having f of 1 over 2022 supposed to give me an integer. So I'll divide that over. And yeah, maybe I'll just shift this over so I have f of y as a standalone. Okay. Now this is very full of product stuff, and this is also somewhat symmetric. So the two things that I want to do at some point, I can't put in 0. I would love to put in 0, but I can't put in 0 because they're positive reals. I mean, the trade-off is I'm allowed to divide because they're all positive reals. I want to put in 1, and I want to swap x and y at some point in time. Right? Because when I swap x and y, I can reap the symmetry. So let's see what we can do. Now for this equation down here, if I want to substitute in 1, I can put in x equals to 1 or y equals to 1. I think y equals to 1 is a little bit nicer in terms of what it turns out to be, but remember we're going to swap it later, so it doesn't matter which one we actually put in first. Now, here I'm using a substitution there. And so we get f of x plus 1 over x of x equals to f of 1. Now, as a quick side note, this tells you that actually f is injective, but I don't think we need that here. Right? It does tell you f is injective. So functional equations, one thing we always look for is surjective and injective. Here it does give you injective. Not needed, so I'm just mentioning that as a side note. Well, what do I want to do with this? I think that f of 1 being equal to this is not so important, but now f of x can be written in terms of something without the iterated f. So it means that now, anytime when I have got f of f, I can replace it, which is a good thing. Now, there are no iterated f's in the expression unless I put y equals to 1, which I've just done. Right? So I can't put in a value to make this happen. How I could make it happen is to replace one of these, either replace x by fx or replace y by f of y. So I will replace y by f of y. The reason is that if I replace x by f of x, I'm going to have something very messy on the inside. So I want to replace y with f of y. I can replace y by f of x, but I want to still maintain flexibility with two different variables so I get more substitution power. Okay, some of you have always asked, why can we do something like y is equal to f of y? Now, I'm not saying y is equal to f of y. I am replacing y by f of y because here the x and y are just dummy variables. It's just like a function. I can say fx is sine x, therefore fy is sine y, therefore f of 2x is sine 2x, therefore f of x squared is sine x squared. I'm not saying x equals to x squared. I'm just replacing, right? We can always do that. So x fx x y. And now this is very symmetric, but I want to put in the f of x equals to f1 minus 1 over x of x, I wanted to have that available to replace, right? So that's exactly what I'll do first. And what do we do from here? Well, I mentioned about symmetry. I want to swap x and y. So I'm going to swap x and y. And I anticipate this will be the first question and only question in this where I actually need to open up a new tab to continue writing. So this is very symmetric, right? They're almost exactly the same. F1 and F1 is repeated. This and this is repeated. This and this is repeated. So it's almost the same. I can subtract them in order to bring that out. So let me copy this over and I'll just open up a new frame so that we can continue writing all the stuff. Give me a second to get that. Okay, we'll probably need back the original question later, but we will get that when we need it. So the difference between them doesn't look like it's doing very much, but it's all in fractions, so it's hard to see whether it's doing very much. Okay, and I can clear all the denominators with my x, y, fx, fy. Clear everything. And this comes out to be pretty nice. Now this is pretty nice because the x and y's have finally been separated. Now this is the whole thing that we're driving at, right? When we can swap x and y, it means that all the symmetric terms remain, and the things that don't remain are those that only contain x without y or y without x to a large extent. So when we take the difference between them, we can separate them out. And now we can say that yfy minus y equals xfx minus x. And this is the same on both sides. So it finally implies that the function here, if I call it g of x, xfx minus x is constant. So we're almost home. We have got the information that this is constant. So xfx minus x is equal to some c. Fx is equal to 1 plus c over x. And we can use, well, anything at all if we want to extract out what is the value of c. Right? We can take something like this intermediate expression over here, and yeah, let's just see whether it works. So f of x, we are now saying we know that fx equals to 1 plus c over x. So I can put something like f of 1 is supposed to be equal to 1 plus c. So let x equals to 1 and just solve. Right, so f of 1 is f of 1 plus c equals to 1 plus c minus 1 over f1. So 1 plus c over 1 plus c. Is this just trivial? Have I got something redundant? I hope not. Let me check. Okay, no, this is not redundant. Okay, I wanted to make sure that I haven't gotten something redundant, but no, this is exactly right. If you cancel this off and you shift it over, you just get 1 equals to c. For a while, I thought we got 1 equals to 1, and that would be very depressing. But no, we got 1 equals to c. So we have finally gotten the function. Now again, this is another question that could be in the SMO senior or even SMO open second round. But if you were in the second round, of course, that would be considered relatively doable by second round standards of the SMO open. But there we go. This is the last problem, and I think the effort is kind of worth it because you can't really guess 1 plus 1 over x from here that easily. It's not one of those where fx is 1 and then you wonder why you did all of that, or fx is x, right? This one is less obvious than that, so I think we can take and accept that. Right, so before we end off, again, thanks for joining in. I hope the review session is useful, as well as the mock papers before this that some of you tried along with last year's review. If you have any more questions, feel free to ask. I'll leave the stream open for a little while longer if you want to discuss or you want to clarify anything. Now, the open round 2 is really difficult, so if some of you, because you let's say you're in year 5 now, you think you're going to get into the second round, year 5 or JC1, but the last time you took a second round was junior round 2, please start taking a look at open round 2 questions. They are really difficult, so you need to be prepared, right? It is going to be a huge shock if you suddenly realize that, my goodness, I can't do anything. That's not unusual, it's just that you need to at least be prepared so you know what is going to happen, right? So yes, that's all we have for now. Thanks for joining in on this evening. If you have your simulcam tomorrow, then rest up well as well. And yeah, I'll just go off camera now and leave the stream open for a brief period if you have questions or want to discuss anything. So thanks everyone and good night.